Hi class, this is Mrs. Snowbeck. Today we're going to do Unit 5, Lesson 3, and it is about similar triangles. And I want you to think back a couple units ago we studied triangles and we found 4 shortcuts for checking if triangles were congruent. And the 4 shortcuts were this. They were side, 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 angle, side, angle, and angle, angle, side. And if you had 2 triangles where the combinations here appeared, where the sides or the angles were congruent, then that was enough to know the triangles were congruent. Well, there's also some shortcuts for triangles to tell if they are similar. Now remember, similar means same shape, but different sizes. So one might be smaller than the other. Same shape, different sizes. Whereas congruent means same shape, same size. So here's the 3 tests. Angle, angle, side, 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 and side, angle, side. Those are the 3 shortcut tests. If you have one of those 3 items, you will have enough information to know that your triangles are similar, meaning the same shape, but they might be different sizes. Now, the angles have to be congruent, but the sides have to be proportional. So let's just do some examples and I think you'll see what I mean. Number 1, determine whether these triangles are similar. If so, write some similarity statements. Well, in the past, to check if they were similar, we had to check all the angles and they had to match up and be congruent. And then we had to check all the sides and we had to divide the sides and see if we got the same answer every time. Well, let's see if we can just get one of these shortcuts. So one of the things I know is in a triangle, the 3 corners add up to 180. So I'm going to use triangle ABC and I'm going to do 180 minus 42 minus 58. And when I do that, I end up with 80. So angle A must be 80 degrees. Well, as you can see, we have an 80-degree angle and an 80-degree angle, A and E. We also have a 42-degree angle and a 42-degree angle. So we have angle, angle. We have 2 angles that are congruent. That is automatically going to make these 2 triangles similar. So we would say yes, triangle ABC is similar to triangle. Well, we have to match this up. So A matches with E, B matches with D, and that would leave F. So EDF by angle, angle. And that would be our answer. Okay, so remember our 3 choices are angle, angle, side, 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 and side, angle, side. These are our 3 choices for checking if a triangle is similar to another triangle. So number 2, determine whether the triangles are similar. If so, write a similarity statement, explain your reasoning. There's not much marked here on these triangles, but I do know a few things. I see those red arrows, and that means that they're parallel. So remember, if you have a line that's parallel to another line, and then you have a transversal cutting through, you're going to get some alternate interior angles. And so angle P and angle M are going to be congruent by alternate interior angles. I'm just going to clean up my picture here a little bit. So those 2 are congruent because they're alternate interiors. Also, these 2 angles, they're vertical angles and they are also congruent to each other. You know what? We can stop right there because we have angle, angle. So I would say yes, triangle QPX is similar to triangle, now we have to match it up, so it'd be NMX by angle, angle. Let's try number 3. Determine whether the triangles are similar. If so, write a similarity statement and explain your reasoning. So right off the bat, I know these 2 angles are congruent. They're vertical angles, they will be the same size. But we don't have any parallel lines this time, so we cannot check to see if we have alternate interior angles. That won't work. So what we're going to have to do is we're going to have to check some of the sides. So the longest side on the left triangle is the 9. and the longest side on the right triangle is the 6. Now let's divide those. It's kind of like finding the scale factor. So 9 divided by 6 is 1.5. All right, let's find the shortest side on each triangle. Well, the shortest side on the left triangle is the 6, and the shortest side on the right triangle is the 4. So let's divide those two numbers, like checking for a scale factor. 6 divided by 4 is 1.5. And then finally, we're left with the middle length side, which is 7.5 and 5. And if we divide those, 7.5 divided by 5, we get 1.5. Haha, we got the same scale factor for each of those sides. And so they will be similar. So we can say something like, yes, triangle ABC is similar to triangle, let's see, we have to go where the pink and blue met, so that's going to be D, and then E, and then C. So triangle ABC is similar to triangle DEC by, and we have two choices. We did check all three sides, so we could say by side, 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 they all had the same scale factor or the same ratio. And we could also use side, angle, side, where we use the blue ones and then the angles at C there and then the green ones. So we could use that as well. So we could say or side, angle, side. Now you only need one of those. You don't need both, side, 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 and side, angle, side. Either one is correct. Number 4, determine whether these triangles are similar. If so, write a similarity statement. Explain your reasoning. So the two triangles that we're talking about are this little triangle up here in red, and then this bigger triangle down here in blue. And so one of the things I notice is angle M. Angle M is in the big triangle and it's in the little triangle. So they do have one angle that is congruent. However, I don't think we know anything about the other angles at this point. So what I want to check next are the sides. So on the red triangle, I have a side of 10. Now the side that corresponds with that on the blue triangle is going to be 10 plus 15. So it's going to be 25. So I'm going to find that scale factor. 10 divided by 25 is 0.4. Now I'm going to check the other side. So on the right side of the red triangle, or the small triangle, I have a 12. And on the right side of the bigger one, I have 12 plus 18, which is 30. So I'm going to compare the 12 to the 30. If I divide those, again, I get 0.4. So I got the same ratio of sides. So I don't know the bottoms of those triangles, so I think I have enough information. I think I have a side, an angle, and a side in each of the triangles. So I'm going to say yes, the small triangle, triangle NMP, is similar to triangle RMS. And this time it's by side, angle, side. The sides were proportional and the angle was congruent. Number 5, segment RS is parallel to segment UT. RS is 4, RQ is x plus 3, QT is 2x plus 10, UT is 10. Find RQ and QT. Okay, so they've marked all of that information already on these triangles, so we really didn't need to really read the question, except for to figure out what we're trying to solve for. So these triangles are not congruent. They are not the same size, but they might be similar. And so because these sides are parallel to each other, we're going to wind up with some alternate interior angles. And so what we're going to think about is which angles would be congruent. I think angle T and angle R would be alternate interiors. Because again, we have this is parallel to this, and then this cuts through. So see how those two would be alternate interiors? We also have the vertical angles. So these two angles right in there at the the vertical angles there at Q, they're congruent. So we can stop because we have two angles that would be congruent. These triangles are similar. So I'm gonna make that little note here. Triangles are similar by angle, angle. Just to remind myself, I figured out these triangles are similar. So if they're similar, I can write a proportion. So I need to figure out what sides match with what. Well, the 10 on the left triangle is between the double mark and the empty angle. So it's, you see here I have a double mark, and right here I have an empty angle. On the other side is the 4 in that spot. So the 10 matches with the 4. Now that should be proportional to, I'm going to use the 2x plus 10 this time. Now notice the 2x plus 10 is between the double angle and the red angle. And so over here between the double angle and the red angle, I have x plus 3. So they match up. I've made my proportion. Now I'm just going to solve. So how do I solve? I'm going to cross multiply. Multiply those, multiply those. So it's going to be 10 times x plus 3 equals 4 times 2x plus 10. You're going to have to distribute. So you get 10x plus 30 equals 8x plus 40. Combine your like terms. 2x plus 30 equals 40, minus the 30. 2x equals 10, x equals 5. However, we are not done. We have to find, remember it's asking us to find RQ and QT. So for RQ, that's up here in the green. It's x plus 3, but x is 5. So I'm going to do 5 plus 3, which is 8. So that's RQ. And then the other one, QT, is going to be 2 times 5 plus 10. So I just take that 5 and plug it in right there. So that is 20. QT is 20. Number 6. Josh wanted to measure the height of the Sears Tower in Chicago, which, by the way, if you've been to Chicago lately, it is no longer called the Sears Tower. It's called the Willis Tower. It used to be the tallest building in the United States. It's not anymore. He used a 12-foot light pole and measured its shadow at 1 p.m. The length of the shadow was 2 feet. Then he measured the length of the Sears Tower shadow, and it was 242 feet at the same time. What is the height of the Sears Tower? So what we're going to do, you guys, is we're going to make a ratio. So they've got this little tiny light pole down here, and it has a shadow of 2 feet, and it is 12 feet tall. And then we're trying to figure out what's the height of the Sears Tower, and its shadow is 242 feet. So we can make a proportion, and there's more than one way to set up your proportion. Here's what I would do. Let's do height over shadow. So we have the Sears Tower height over the Sears Tower shadow. And then we have the light pole height over the light pole shadow. So we did height over shadow, height over shadow. Now that's one of the correct ways to set it up. There's other ways as well. So now I'm going to cross multiply. So we're going to have to do 2 times x, which is 2x, and we're going to have to do 12 times 242. So 2x equals 2904, and then divide by 2, and we wind up with x equals 1452. So that would be labeled feet. So in other words, the height of the Sears Tower, according to this proportion, would be 1,452 feet. If you Google it, it says it's 1,450. So this is off by 2 feet. Why would that be? Well, there could be some human error involved, right? When he measured the shadows, maybe it wasn't exactly 2 feet or exactly 242 feet. He might have made an error. Or maybe he rounded. Or maybe by the time he got over and measured the second shadow, the sun had shifted a little bit, and so the shadow wasn't exactly measured at exactly the same time. Lots of things could have happened. Number 7, triangle ABC is similar to triangle DEF. Solve for R, T, and Y. So one of the things I notice is R is here at angle F, and that's the only place I see an R. So I go up above and I see angle F is the last letter, and that would match up with angle C in the other triangle. Now remember, if shapes are similar, their angles are still congruent. And so their angles have to be the same size. 2R plus 4 must equal the 38. The sides won't do that, but the angles will. So we can solve this. We get 2R equals 34. Divide by 2. R equals 17. Next, let's look at the Y's. I see two Y's. I see one at angle A and one at angle B, but I don't see any in the other triangles. And so I have to think about this a little bit. Is there something I can do? Like I see A is the first letter, it would match up with D. Is that helpful? I don't think so, because one has a Y and one has a T. Or if I look at B, B matches up with E, but there's nothing there. So that's not really helpful for me. So I'm going to have to come up with some other method for finding Y. And I got to thinking about the big triangle ABC. I know something about the three corners. The three corners, or the three angles in every triangle, add up to 180. So what if I just did 5y minus 1 plus 4y plus 8 plus 38 equal 180? Yeah, I can do that. So 9y plus 45 equals 180 minus the 45. So we have 9y equals 135. Divide by 9. Y equals 15. And the last letter we need to solve for is T. So the only T that I see is here at angle D. Angle D matches up with A. And before, that wasn't helpful. But now I know Y, and I can take the Y and I can plug it in there. So I can say something like 5 times 15 minus 1 equals 3t plus 11. Because remember, angles will be congruent in similar figures, and these figures are similar. So next, 5 times 15 is 75. 75 minus 1 equals 3t plus 11. 74 equals 3t plus 11. Minus your 11. And 63 equals 3t. Divide by 3. T equals 21. Boom, we did it. I think we solved for all the things they asked, R, T, and Y. So that wraps it up for Unit 5, Notes 3. Now you're going to try the practice. Notice I'm giving you a little hint on number 10. That's a pretty hard one. So maybe when you open that, go to number 10 and make a little note. You have to do Pythagorean theorem first on that one to find one of the side lengths. Remember, Pythagorean theorem is a squared plus b squared equals c squared. So you have to do that first, and then you'll set up a proportion. It's a challenging assignment, so if you get stuck, just send me a Schoology message and I'll try to send you a hint on how to start. Have a great day.